This video segment is on the modeling of a planetary gear in Catia. Planetary gears are very common in machines, and let me show you the situation here. This is the one that I did in class, and I'm recording this in case you want to repeat it yourself. So basically, you have a ring gear with the big one. You have a sun gear right there, and this is the planetary planetary or planet gear which is going to turn around this, and these are connected through a carrier. Now I do not model the teeth of these gears, but let's remember from our third year machine design course that the number of teeth on this is proportional to the radii of these things or the diameter. So for the present problem, I'm assuming that the sun gear have 72 teeth. Sorry, the ring gear has 72 teeth, which is bigger, obviously, and the sun gear has 30, which is smaller. So instead of dealing with teeth, I'm going to assume that these are, for example, in millimeters or inches. As long as I'm consistent, it doesn't matter. So let's say that I'll make it uh, millimeters. Okay, good. I'm going to make these millimeters and make the parts. So let's start with making first of all, a base. This base is going to stay there. You can imagine that this base is actually, this base, or called shaft, actually, I'll call it shaft. This shaft is actually connected to the engine where the torque is being delivered to. Okay, so you can imagine that's the case. All right, let's go ahead and make it. Uh, all right, immediately I save this thing, file, save management, save as. I have a folder here called, I thought I made a folder, planetary gear, oh, right there. All right, save as. And I'm going to call this thing, how about the shaft? I'll call this thing shaft, okay? All right. And all it is a cylinder, really. So, oops, I don't know why I called it the shaft. I don't know why I renamed that thing. So that's not what I meant. So insert a new part in there, and I'm going to call this thing a shaft. That was a boo-boo. I should not have done that. Say, change the name of that thing. So anyway, so I'll call this thing a shaft and a shaft. So okay, and all it is a cylinder. So double click on a convenient plane. I'll make this vertical plane, which is the y-exit plane, as my starting location. So all it is a disk. Let me give some dimension here. Actually, just for me to have an idea what's going on here, let me dimension this thing to be something. It says this seems to be in inches, right? So I'll go with uh, maybe 20 inches. Sorry, 20 millimeters. See how it looks like. Okay. Exit. All right. And I'm gonna actually change my units to millimeters. How about that? Tools, options. For length, I'm gonna use millimeters. Okay. It's totally irrelevant in this problem. Good. Now exit. I'll do it in the other direction. So that's going to be the shaft of this planetary gear, which is driving the torque basically from the engine. So let's make it 40. All right, good. Now we go all the way to the top, insert the sun gear. So insert a new part. I'm going to call this thing sun. Right click properties. Sun. No, actually, sure, sun. Yeah, sun. And sun. Let's go make it. Double click on this. On a convenient plane. On that same plane, I'll sketch something that is 30 millimeters. Now, notice that I made this shaft to be 20. Let's go ahead and draw that, see how it looks like. So this is diameter. Uh, Let me make diameter 30. Okay, so there's the shaft, there's the sun gear. If this is bothering you, you think it's too big, you can go change it, but it really doesn't matter to me. I just leave it the way it is. Exit, and then pad it. Let me make this thing, maybe we pad it by 10. Okay, so that's going to be the sun gear. Okay, all the way to the top, insert a new part. Call it, I'll call it ring. That's the outside one. Ring and ring. Let's go make it. On a convenient plane, on that same vertical plane, I will sketch. This time I'll draw a circle with a diameter of 72. Remember, this diameter was 30. I'm going to make the diameter of the ring out there 72. I think that's what we had, right? Let's find out. Yeah, the sun has 30, let's say millimeter, actually number of teeth, and the ring has 72. Okay, so that's good. Let's make a circle of the diameter 72. 72. Okay. Now, because I want to give it a three-dimensional, think about it as a three-dimensional view, somehow, let me check for a second. Yeah, maybe they look okay. Yeah. So I'm going to draw another circle. Outside of that, it's basically to make a three-dimensional ring object out of it. So exit, I made these things 10, so let's make it 10. Good. Why don't I change the color of these things too? So right click properties. I'll make this thing yellow. Okay, the sun, I'm gonna make this thing maybe blue. Graphics, make it blue. Where's it blue? All right, that's fine. Okay, and the shaft, we leave it the way it is. Now we are going to make the planetary disk. So we go all the way to the top, click on the floppy, and insert a new part. Oops, sorry, again. Insert new part in there, and I'll call this thing planet. Right click properties, planet. Where is it? Planet, planet, and planet. Okay, let's go make it. So we go down here, we go to the planet on that same vertical plane that we drew the other ones. I will sketch. I want to sketch a circle that's tangent to both of these, so it's not hard. So I'll just draw a circle here first of all, and then I'm going to say this guy, control that guy, or tangent. Okay, And repeat the same thing with this and that. Okay. So this fellow, control that fellow, also tangent. Okay. Okay, so that's going to be the planet exit and pad it by also 10. This is just for visual purposes that we're doing it like that. I'm going to change the color of this thing. Right click properties. I'll change the color to maybe green. Okay. The last thing we want to do is to create a carrier. So we go all the way to the top. So insert a new part, carrier. Oh, yeah, properties. I'll change the name here. Carrier. Carrier. Let's make it on that vertical plane. Oh, well, actually, let me do that on that, on this, on one of these faces. It doesn't matter. Just to minimize my job, to minimize my work. That's all. Okay, so let me see now. Why don't I make this thing uh, an elongated hole? How about that? So yeah, let me do that. Elongated hole. This is going to be the center of one of them. And then with the other center of the other one, we're going to fix it in a minute because I don't know where it is. But we'll do that. So the carrier looks like that. Now let's think about it for a second. The center of that, notice that the this this radius was half of 30. So that's 15. This radius is 15. Remember the diameter was 30. This radius is 15. And the radius from here to here is 36. To the ring is 36. So 36 minus 15 is 11. So what that means is the distance from that location, okay, uh, there's an easier way of doing it. So select this, control that circle, and make him concentric. How about that? That's better than calculating all these radii. Very good. Now we know everything is okay. Exit and we pad that, and you can see why I drew it on this because it's easier for me to visualize that. So I'll make it maybe 4. There's the carrier. Okay. This thing still bothers me, so let me go make it smaller. So I go to the shaft. Still bothers me. It's too big, in my opinion, for visual purposes. I'm just gonna give it dimension. Yeah, that dimension. I'll make it maybe 8. Yeah, I like that better. Okay, so let's change the color of that. Right-click properties on the graphics. I'm going to change this color to maybe pinkish. Okay, good. All the way to the top. All the way to the top. Save everything. All right, so let's go ahead and do the assembly process. And minimize the tree. All right, so let's go here. Let me go to assembly design. I'm going to fix this shaft. So anchor that shaft. Okay, good. Now create a revolute between later on revolute between this sun and that shaft. Okay, so coincidence. Well, the best thing to do is to move these apart first of all. So let me move these apart. Translate in the direction 1. So translate this and that, and that. Okay, good. Say, okay, that one is fixed. The shaft is fixed. Coincidence between this axis and that axis, there's nothing to update because I just translated them. And coincidence between this guy and that face, for example. Okay. So update, they're going to stick together. Okay. Now, there's a revolute between this fellow. Let me put this thing in place. How about putting, yeah, let's put this ring in place. So coincidence between this axis and that axis, of course, and coincidence between, for example, this plane and that plane. Okay. Okay. Now let's put this thing in location. So, well, how about me putting the carrier in place? So coincidence between this axis and that axis, and coincidence between this plane and that plane. Okay. Now, same thing here. Coincidence between this plane and that, sorry, this axis and that axis, and coincidence between, for example, this plane and that plane. That actually doesn't have to be revolute. It can be, it will be actually, even if it's cylindrical, it's okay. Oh, if I have to flip the, I think I have to flip the direction of the arrows. Good, that's better. All the way to the top, all the way to the top. Okay, now, what I'm going to do is I will go and create all the joints and something that I may not like, I'm going to delete or add stuff. So we go to the digital markup, DMU kinematics, get the magic wand out, new mechanism, auto create, say, okay, my guess is that there will be 4 revolutes here. Yeah, 4 revolutes. Okay. All right, good, good. Now, uh, let's make first of all this shaft is going to be fixed. I'm going to assume it's fixed. Okay, this blue one, which is called the sun, we're going to make it angle driven later on. Okay, no problem. But this, instead of making gear joints between these things for the present problem, it's easier if I did what is called a roll circle, roll curve joint instead of gear joints. Okay, because these two I can use a gear joint that we have. We have done problems like this, gear joint. Okay, but instead of doing it like that, I will use the roll curve joint. Roll curve between this guy and that guy. That will reduce some of these degrees of freedom. Okay, what is complaining is that there is a distance between them, and I'm really surprised because I thought I did it so that they touched each other, but that's weird. See, it says oh, sorry, millimeter, 0.05 millimeter, but I'm surprised because uh, let's see why that happened because I did had these things the same amount, did I not? Uh, okay, let's do it different way. You know what? Probably between these two there is an issue too. Let's check it out. Between this curve, let's see if there is also that distance. This one is okay. All right. It didn't want to do these two, okay? And I'm not sure why, and I don't want to go and clean things up. So let's do it different. We already did the roll curve between this and that, no problem. Now, yeah, these two have to roll on each other. So why is it that it's not doing it? Try it. Let's try it again. So another roll curve. I'm very surprised. Let's check these two back. The one in the back, which are going to suffer from the same issue, I'm sure. Yeah. See that? So the question is, why is that? Let me do the following. Let's go and check a few things. We go here to the padding of this. That would have been the sun, right? Pad of the sun, 10 millimeters. That's okay. The planet, 10 millimeters. No problem there. Something that's bothering me. You can see, I'm not sure if this, I'm not sure if that thing is completely centered. Maybe it is. Let's go ahead and find out. This is a view from let's look at the view from the front. No, view from the side. Nope. View from this side. Yeah. See, these things don't seem to be centered. They're supposed to be. Remember, I made this thing concentric with the other circle? I don't think it has happened. Let's go ahead and find out. Uh, Let me go check. Yeah. See that guy? See this? It's not at the right location. Let's go ahead to our, we did this thing in the assembly constraints, right? So, was it this? Let me do the following. Let me cancel that. I'm going to, this is the one that seems to be causing problem right there. I'm going to say, okay, let me delete this and put another constraint there. Yeah. So we go to assembly design. Make a coincidence between the axis of this and the axis. You see that? That's what's causing the problem. And that may cause an issue for the thing that I made in the back. We'll find out. Okay, so let's update the assembly. Good. Now it's good. Now it's good. Okay, so let's go back to the model. Yeah, another roll curve that I couldn't do before. A roll curve. We have to go to digital markup. No problem. Let's go here. Go through that. So a roll curve. Cancel that for a second. Roll curve between this and that. It would not do it before. It said that there's a distance, etc. Now it's okay. Okay, good, good. So what do we have here? We have this planar one actually, because of what I did, it take one of those revolutes and convert it into planar. Okay, so actually, I wanted that to be Revolut because of the constraints that I did. It was easier. Believe me, it was easier if I deleted this mechanism And once I fix this thing, go and do it again. But because of what I did, that revolute was lost and became planar. Okay, so what I'm going to do is bite the bullet. I'm going to delete this. Don't delete the children. Don't delete the children. Okay, go and create the mechanism again. It is possible to fix it, but sometimes, at least on an exam day, it may not be worth it. New mechanism, auto create. Probably now I get 4 revolutes. Yep, yep, yep. Now let's try to do our roll curves. So roll curve between this guy and that guy, all right? And another roll curve between this and that. It's going to work. Okay, the degree of freedom became 2. Now, yes, because this is a 2 degree of freedom system. This is a 2 degree of freedom system. So if you look at the problem description, which let me bring it up for here for you. Yeah, so it doesn't say there, but this is a 2 degree of freedom system. So don't try to make this thing 1 or 0. Okay, you can, but here's the way it's going to, this is how you make it 0, but that's artificially. See, length driven, yeah, length driven, fine. Or, yeah, okay. All I'm saying is that this is a 2 degree of freedom system. Don't bother too much with trying to, uh, uh, okay. Now, this is a 2 degree of freedom system, and we're going to put some physics into it. So, for example, notice that we have to fix something. For example, let me rigidly attach the sun to the shaft so that this sun, not the sun, the ring to the sun, no, ring to the shaft. So, rigid joint between the ring and the shaft. That makes this thing 1 degree of freedom. And this is why these tables matter. It says, what is fixed? Is the ring fixed? That's what I just did. Okay. Is the sun fixed? And if that's the case, you have to go and do it again, etc. The carrier fixed. So the process is the same. So what do we, degree of freedom is 1. And for example, let's start turning the this is the sun, right? Turning the sun. So sun and the yeah, for example, sun and the not that. Let's actually try to move this thing. So sun and the planet, or planet and the ring. It really doesn't matter. The mechanism can be simulated. So there's no, we didn't put any physics into this. The mechanism is working the way it's supposed to. Yeah. Notice that in this problem, the sun and the planet and the carrier are moving. The ring is fixed. You can see that. We said. Let's go back here instead of fixing, for example, I don't know, fixing the ring. Let me delete this. Fix the sun. Okay, so I'm going to create a rigid joint between the sun and the shaft. That becomes 1 degree of freedom, okay? Except that, let's see how it works. So uh, get this guy out. And notice that the direction changed. The direction changed. The direction of rotation changed. So when the sun is fixed, okay, uh, the gear ratio becomes that. And what else? If the carrier is fixed, if the carrier is fixed, let's go and fix the carrier. I'm going to delete this and fix the carrier, rigid joint between the carrier and the shaft becomes a single degree of freedom system. And what is it? Look what's turning. The sun is turning. The sun is turning, and the ring is turning. You can see that. All right. Now look, I'm not putting any physics into this thing. What I'm trying to show you is that this problem is modeled. Depending on what you fix, you get a certain gear ratio, and also the direction can be changing too. Direction of the rotation of the gear can change too. Okay, there is no physics. I'm not verifying these things. To verify these things, you have all the necessary knowledge from the first 7 weeks of the course to go and find out what is the gear ratio, etc. All right. Good luck.